Normally, developers run tests on apps by interacting with it. This is called manual testing. At first, this is fine when you have a small amount of features, but as you keep adding more features, you'll quickly spend more time manually testing than adding value to your app with new features. Let's imagine this is the program that you're working on. You have different parts of your program, like UI, API, or different systems, and then you have different features for each part. Let's say you're working on this feature, but when you want to test that, you might affect these features. When you manually test, it's pretty easy to prove that all of these features work, but it's a whole lot harder to prove that all of these features over here work. Basically, anytime you make a change to any feature here or here, you would then need to run tests on every piece of the app to prove that it didn't break anything. This leads to pretty boring work. Anytime anyone changes anything, you then have to go run a couple hundred tests over and over, and if a defect's found, you'd have to go test everything again. The other problem you have is if you're testing the screen feature, then it might be broken because of this code, but it might be broken because of an interaction here and an interaction here. You don't actually know what broke the code, except for it's just not working, until everything works together, so you're not providing any value until you can find out what has caused the system to break. On Google's testing blog, this article about just say no to more end-to-end tests. And they said in theory, developers like them because it offloads testing, managers like them because it simulates real users, and testers like them because they can find the bugs that they normally would have found with their test script, except for they've automated their test script so they just know they're always being ran. But the problem is, really, when you get to this example of what a theoretical project might look like, where a day before you release, you find all your tests are broken, a different team deployed a bad build, another day a dev broke a scenario, and then half the tests just started failing. You spend another day troubleshooting, then you get hardware failures in the lab because you need all the software set up and running properly, especially if you run on multiple systems, that could cause some problems. You get to the point 5 days later where you have 84% of your tests passing, but there's still a bug behind the main bug, and eventually you didn't change anything, but the tests get to a level that you're happy with. The real problem here is that a failing test provides no value, a bug open creates no value, but the only real value is when you fix a bug. So you have to shift your tests to unit tests or API tests. So while end-to-end tests are good and you want to have some, you want to limit your testing because it's slow, it's not reliable, and it doesn't tell you where the problem is. As a rough guess, Google suggests you should have a 70-20-10 split, with 70% of your tests being unit tests, 20% of your tests being integration tests, and 10% being end-to-end tests. And even with that split, I almost guarantee that your end-to-end tests will take longer to run than your 70 or 20. Let's pretend this is the app we're building. We have a UI and we have an API. The UI is just written in HTML and JavaScript, and the API is just written in C#. It's pretty easy to test that our UI works because all we have to do is enter a number, then hit search and see how many results come back. So here we can see we have 2 results, and if we type 10, we can see we have 10 results. And if we just run a search with no number input, we still get 10 results. So that's easy to test, but when you're manually testing and you're running those kind of tests a lot, it's kind of inefficient to run these tests. And also, how many different iterations do you want to do to prove that your API is working? Validating your data with UI testing is generally not the best case scenario. What can you do to fix that? Here I have different tests created that can help test this. We have a unit test suite that can help us tell that the car controller is returning the values that we expect. We can run these tests very quickly because unit tests generally run in 1/10 of a second. Anything longer than 1/10 of a second for unit tests is generally considered a long test. The next set of tests I have are the API tests. Here I'm using REST to send REST messages to my API to prove that I'm getting back the results I expect. So when I send cars 10, I get back 10 items. When I send back cars 3, I get 3 items. You can see that these are taking about 2 seconds a message. So they're much longer than our other test set, because if we had 100 of these, it would be 200 seconds to run. Whereas if we had 2,000 of these, it would still probably not even be a second to run. And then I've got another set of tests here that are using Playwright. And what they're going to do is actually hit the page. So they're going to do the same tests that we did manually. So we're just going to run those tests here. As you can see, the browser's popping up, running through these tests in an automated fashion. And you can also see that these tests take a little bit longer. And the difference between these tests and the API tests is that for every API call, it's actually going to run. I'm only going through one API call here, so they're really running about the same speed as the API tests. The bigger your app gets, the longer that these take. The more that you add to these tests, the flakier they get, especially if you go through something like 25 steps. If any one of those 25 steps breaks, the test just fails. But for a lot of reasons, if a test fails, you really have no idea why it failed. These are generally the least valuable tests. If all you have is these end-to-end tests that test your app through the browser, then you're probably going to want to get some tests on the API level and the unit test level. I also have a set of tests that run from Jest. They're not loaded into this solution, but I can run the npm package from here. And you can see here that my JavaScript tests also passed. So up here I was testing C#, and down here I'm testing my JavaScript, and I have a test suite with 2 passing tests, and those also run extremely quickly. And the great thing about all these automated tests is that they can run in a pipeline. So if you have something like Jenkins, you can have all of these tests being run on your app every time you commit a change, so that they're constantly being run. So that way, the second someone changes code and something breaks, you immediately get a signal that something's wrong and you can go fix it. Because it's a lot easier to go fix things when a test breaks immediately